Hello students, in this video we are going to discuss about sets. Okay, sets. So what is a set? So set is nothing but a set is a collection of well-defined objects. Okay, so collection of well-defined objects. So what does it mean? Suppose we have two collections. Suppose this is collection 1 and another collection, that is collection 2. Okay, here we have A, E, I, O, U, and here we have A, B, C, 1, 2, 3, Monday, Tuesday. Okay, so here you see this collection is well defined. Okay, well defined, because we can say this is a collection of vowels of English alphabet. Okay, A, E, I, O, U. But here you see, so here this collection cannot be defined. Okay, in one statement. Here you see these are alphabet, numbers, days in a week. Okay, so this is not well defined. Okay, so this collection cannot be a set, but this can be regarded as set. Okay, so that is the definition of a set. Okay, now representation of a set. So how to represent a set? Okay, there are two methods to represent a set. Okay, so let me tell you the two methods. First one, tabular method. And or you can say tabular method or row star method, or you can say row star method or row star method. Suppose we have a set A. Okay, it is a set of natural numbers less than 5. Okay, so we have a set A. So what kind of set it is? Set of natural numbers less than 5. Okay, so in this tabular method or row star method, so we used to write the set, we used to write all the members of this set one by one within bracket separated by comma. Okay, so natural numbers starts from 1, 2, 3, 4 up to infinity, but here it is said that natural numbers less than 5. Okay, so A is a set of natural numbers less than 5, so we can go up to 4 only. Okay, so that is how we can represent a set in tabular method or row star method. Okay, and our next method is set builder method. Okay, set builder method. Okay, or it is also known as rule method. Okay, it is also called rule method. Okay, so let me take the same set A here. How to represent this set A? How to represent this set A that we have represented in tabular method? So let me show you how to represent this set in set. So in set builder method, set A can be represented as X such that X belongs to capital N. Capital N means capital N means set of all natural numbers, set of all natural numbers. Okay, so x such that x belongs to n and x is less than 5. Okay, so we have written this same set A in set builder form. So what was the set here? 1 2 3 4. Okay, these are what? These are nothing but natural numbers and these are less than 5. Okay, that's how we can represent a set in rule method or set builder method. Okay, so now let us solve some problems from Ncert textbook of mathematics class 11. Okay, so here is the first exercise. Okay, this is the first question of this exercise of Ncert textbook of mathematics class 11. Okay, so which of the following are sets? Justify your answer. So there are some collections given here, so we need to determine those collections are set or not. Okay, so let me see the first collection, the collection of all months in a year beginning with the letter J. So it is obviously set because all the months in a year beginning with the letter J is always well defined. Okay, so you can distinctly identify the months in a year which are beginning with the letter J. Okay, so you can easily identify. So that's why this collection is well defined and hence it is a set. Okay, and the next collection is the collection of 10 most talented writers of India. So when you see such kind of collections, most talented, most beautiful, most intelligent, okay, then those kind of collections are not well defined. So that's why it cannot be a set. Okay, I hope you have understood. So let's move on to the next. Here is the third collection, a team of 11 best cricket batsmen. Okay, so I have already told you, when you have collections like most beautiful, best something else, and most intelligent, like those terms, so those type of collections are not well defined. Okay, because those kind of selections, best cricket batsman or most talented, those kind of selections may be vary person to person. That's why those are not well defined, so you can't say it is a set. Okay, so now you see collection of boys in your class. So in your class, that means in a particular classroom, so collection of boys. So you see, in a particular class, so there must be limited number of boys and you can easily identify that this particular boy belongs to this class. Okay, that's why it is well defined. Okay, that's why it is a. Now you see, our next collection is the collection of all the natural numbers less than 100. As you can see that we can easily identify the natural numbers 1 2 3 4 5 less than 100, up to it goes up to 99. Okay, that's why it is also well defined, that's why it is also a set. So now you see, I am not writing the answers, just I'm telling you the answers and the reason why these collections are set or not set. Okay, hope you have understood. You can write the answer by yourself. Okay, now let's move on to next collection, the collection of all novels written by a writer Manish Premchand. Okay, now you see the collection of novels written by a particular writer is you see, it is well defined because we can identify easily that which novel is written by this particular writer. Okay, this collection is well defined because we can easily identify that a particular novel is written by this writer or not. Okay, that's why this collection is also well defined. Okay, I hope you have understood this. So now let's move on to next question, next collection, the collection of all even integers. So we know we can easily identify the even integers 2, 4, 6, dot dot dot. Again here you see similarly we also get the negative even integers as well. So this collection is also even, though it is infinite, it is not limited, but we can recognize easily. Okay, the which type of elements will be contained in this collection. Okay, so next collection, the collection of all questions in this chapter. Okay, so the chapter about which we are discussing now. So in this chapter there are some certain number of questions, so set of those questions is also well defined, so this is also a set. Now this is the last collection, a collection of most dangerous animals of the world. So I have already told you, when you see most dangerous, best something, or most beautiful, most intelligent like this, so it is never well defined. So I hope you have understood this first question. Okay, now let's move on to next question, question number. So here you can see this is the question number 2. So what to do here, let set A is equal to 1, 2, 3, 4, 6. Okay, so these are the elements. Okay, these are the elements in set A. So remember, the members of a set are called element of that set. Okay, so here we need to insert the appropriate symbol belongs to. This symbol is called belongs to, and this is not belongs to. So this is belongs to. When you cut this represents. So here you see, so in the first one, 5 dash A. So you can see here this 5 element, this 5 is an element of this set A. Okay, that means it belongs to A. So that's why this is the symbol, appropriate symbol, which represents belongs to. So 8, here you see 8 is not present in this set. Okay, in the set A, 8 is not present, that's why doesn't belongs to A. And 0, okay, this set A doesn't contain 0, that's why does not belongs to or doesn't belongs to. You can say 4 dash A, this is 4 here you can see 4, so that's why it belongs to A. 2 also belongs to A, but 10, there is no 10 in this set, that's why doesn't belongs to. Okay, so that is how we can solve question number 2. Hope you have understood. So now let's move on to next. So this is a question number 3. Write the following sets in the roster form. Okay, so there are some sets given here, so we need to write those sets in roster form, that means in tabular form. Okay, so here you see these are written in rule method or set builder method, so we need to write in roster form. So in roster form, what we do, we used to write all the elements, okay, within bracket. Okay, so here you see x is an integer. Okay, it is an integer, not fraction. Okay, such integer that it is greater than -3, less than 7. Okay, greater than -3, that means it must be started from -2, -1, 0, 1, 2, 3, 4, 5 and 6. It is less than 7, that's why it ends up to 6. Okay, so now next B. Okay, here you see x is a natural number, it's a natural number less than 6, and natural number starts from 1 and it is less than 6, so it must be ended at 5. 1, 2, 3, 4 and 5. This is the set of B. Okay, in roster form or tabular form. In next, x, such that x is 2-digit number, 2-digit natural number, such that sum of its digits is 8. Okay, so now we can take 2-digit numbers. Here you see sum must be equal to 8, so we can take 1 and 7, that is 17. 1 plus 7 is 8. Then we can take 2, 6. okay, sorry, don't write 2 comma 6, 26, okay, it must be 26, as sum of 2 and 6 is 8, 26. Then here it will be 35. Then here you see 44, then 53, then it will be 62, so write 62, okay, 62, then 71, sorry, don't write 7 comma 1, 71, it must be 71, and the last one 80. Okay, so these are the 2-digit numbers divisible by, sorry, not divisible by, sum of whose digits is 8. Okay, these are the 2-digit numbers. Okay, sum of the digits of those numbers is 8. Okay, that's how we can write. Now next, set D is equal to, it is a set of x such that x is a prime number. It is a prime number which is divisor of 60. Prime number, you know, those numbers which have no factor other than 1 in itself, like 2, 3, 5, 7, 11, okay, etc. Okay, so we need to find the prime numbers which are the divisor of 60. Okay, a prime number divisor which is divisor of 60. Yeah, so it's very simple. Okay, first let me factorize the 60. Okay, let me factorize the numbers 60 in order to find the divisor, that means factors of 60. So 2 30s are 60, 3 10s are 30, then 2 5s are 10. Okay, so these are, and here you see these are prime factors. Yes, these are prime factors, but here you see we need prime numbers, that's why we are taking the prime factors here. Okay, so that means these are divisor of 60. Okay, 2 3 5. Yeah, so now you see we can write D is equal to 2, 3 and 5, and don't write the same number twice. Okay, so though the same number appears twice, but when you are writing the set, write one element once. Okay, so now let's move on to the next. Okay, the set of all letters in the word trigonometry. So when you write this one as a set, then what to do, you have to write the letters one by one, separating by comma. Okay, T, comma R, comma I, comma G, comma O, comma N. So this O is already written once, so there is also O. We cannot write the same element twice in a set. Okay, then M, then E, then T is already written here, so then again R is also written here, next Y. Okay, so that is how we can write the elements, so we can write the letters in a set like this. Okay, now the last one is set of all letters in the word better. So here also B, E, though there are double T, 2 T's, write only one. Okay, then R. So this is the set in the roster form. Okay, hope you have understood this. So now let's move on to next question. So this is the question number 4. Write the following sets in set builder form. So there are some sets here. Okay, we have to write those sets in set builder form. They are now in roster form. We have to write this one, these sets in set builder form. Okay, so let me show you how to solve. Okay. The first set is what? 3 comma 6 comma 9 comma 12. Okay, so here you see it can be written as, suppose this is equal to a. Okay, so this set a can be written as, here you see these all the numbers are multiples of 3. Okay, so we can write thrice x such that x is a natural number n, and x, here you see this is 3 1s are 3, 3 2s are 6, and 3 3s are 9, and 3 4s are 12. So x must be a natural number 1 2 3 4 which is less than equal to 4. Okay, so we can represent this set in the set builder form like this. Okay, hope you have understood this. Now let me clean this part. Okay, so let's move on to the next set. So what is the set number 2 here? This is supposed B. Okay, what is the set here? This is 2 comma 4 8 16 and 32. Okay, so here you see 2 is 2 to the power 1, 4 is 2 to the power 2, 8 is 2 to the power 3, and 16 is 2 to the power 4, 32 is 2 to the power 5. Okay, so we can write in set builder form like this, 2 to the power x such that x belongs to n, that is a natural number. So these powers 1 2 3 4 are natural numbers less than equal to 5. So maximum we can take 5, isn't it? So less than equal to 5. Okay, so that is how we can write the second set. Now third set is number 3. What is the third set? So here 5, this is suppose C, set C, 5 25 125, then 625. So here you see 5 is 5 to the power 1, then 25 is 5 square, and 125 is 5 cube, then it is 5 to the power 4, 625 is 5 to the power 4. So similarly this one also can be written as 2 to the power x such that x belongs to capital N, represents natural number, such that x is less than equal to 4. Okay, that means value of x starts from 1, ends at 4. Okay, so now set this set, fourth set. So what is there? So this is suppose D, set D. I have written here 2 4 6 dot dot dot. So these are what? These are even numbers. Okay, these are even numbers, positive even numbers. Okay, so now this can be written as D is equal to twice x such that x is a x belongs to n, that means natural number. Okay, x belongs to n, natural number. Okay, that's it, because you see there is no limit, it is up to infinity. So 2 can be written as 2 on the 2, 4 can be written as 2 to the 4, 2 3 is a 6, and 2 into 4, 2 into 5, that's goes on. That's how we will get this set. Okay, so next element will be 8 here, then next one will be 10, so on. So here you see 2 into, these are what? Natural numbers. Okay, that's why I have written here twice x such that x is a natural numbers, that means x belongs to n. So hope you have understood this. So now let's move on to the fifth set. So what is the fifth set here? 149 dot 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 100. Okay, so this is suppose E. Okay, 149 dot 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 up to 100. Okay, so here you see this can be written as what? Now you see 1 is 1 square, 4 is 2 square, 9 is 3 square dot dot dot, and 100 is 10 square. Okay, so 1 2 3 4, these are up to 10, these are what? Those belongs to natural number. So we can write E to the power E is equal to x to the power 2. So here you see power is 2 on every number. So here x square such that x belongs to n natural number. What type of natural number? Less than equal to 10. That means 10 can be included and less than 10 can be included, but it is not greater than 10. Okay, that's how we can write those sets in set builder form. Hope you have understood. So now this is question number 4 finished. Okay, now we can move on to question number 5. Okay, so here you see this is the question number 5. List all the elements in the following sets. Okay, there are some sets. These sets are given in set builder form. We have to write those in roster form. That means we have to write all the elements. Okay, so in the set A, x is such that x is an odd natural number. Odd natural numbers means, so it must be 1, 3, 5, 7 ... goes on. Okay, then set B, x such that x is an integer. It is an integer such that x is greater than minus half. Okay, and less than 9/2. 9/2 is equal to 4.5. Okay, now you see, so 0 and this is suppose -1, so here is the minus half. Okay, after minus half, so 0 is the first integer. Okay, and here 1, 2, 3, 4, then suppose it is 4.5. Okay, before 4.5, 4 is the greatest integer. Okay, so we can include here 0, 1, 2, 3 and 4. Okay, so now let's move on to the next. Okay, so let me clean this first. Okay, now take the pencil. Yeah, set C, x such that x is an integer where x square is equal to less than equal to 4. Okay, we know plus minus 2 square is equal to 4 and plus minus 1 is equal to 1, which is less than 4. Okay, so we cannot take plus minus 3 because its square will be 9, which is greater than 4, so we can't take this one. Okay, we cannot take minus 3 or plus 3 as well, and more than that or less than that. So that's why, so only possible elements here -1, -2. Okay, also we can take 0. 0 square is 0, which is less than 4. Okay, 0, then so here we can take -2, -1, 0, then again +1, +2. Okay, then in the next set D, x is a letter in the word loyal. Okay, so here, so what are the elements in this word? L, O, Y and A. So we are not going to write the same letter twice. Okay, that is the required set. And E, so what we can write here, x is a month of a year not having 31 days. Okay, so what are the months in a year not having 31 days? So first will be February, then next April and June. Okay, September, then November. Okay, so let me write this one again. Okay, so this is the set of those months in a year not having 31 days. Okay, so next set is F. Okay, the last one, this is the last one. Yes, X is a consonant in English alphabet. Okay, precedes K. That means before K, what are the consonant in English alphabets? Okay, so we get B, C, D, not E, because E is vowel, so vowel is not included here, only consonant. F, Z, H, I is also vowel, so J. Okay, so these are the alphabets consonants before K. Okay, that's how we can solve question number 5. Okay, now let's move on to question number 6. So this is the question number 6. Match each of the sets on the left side in roster form with the same set on the right in the set builder form. Okay, so there are some sets on the left side, okay, which are in roster form. These are in roster form, and on the other side these are in set builder form. Okay, so now you see, first set is 1 2 3 and 6. 1 2 3 and 6. Okay, here you see these are all divisor of 6. Okay, that means factors of 6, and those are natural numbers, so that's why it must be C. Okay, X, such that X is a natural number divisor of 6, and here you see 2 and 3 are also factors or divisor of 6, but those are prime numbers, so it must be A. Okay, now you see 1 3 5 7, these are odd natural numbers less than 10, so it must be B. And mathematics, here you see mathematics, so these are the letters of mathematics, so this is D. So hope you have understood this, how to solve this question number 6. So this first exercise is finished now. Okay, hope you have understood. So thank you for watching. If you have liked the video, if you have understood, then please share it, subscribe the channel as